Okay, so we're going to study more about trigonometry in this lesson. Well, the advanced part of trig. Last lesson, we did radians and degrees. So a quick recap. Here's the slide. We learned how to convert from radians to degrees and how the radians are related more to the circle side. And I promised you that I would talk about unit circles. So here I am. So today, focusing on unit circles. What are unit circles? Well, firstly, notice the word circle, meaning that this is actually just related to circles, right? So if we enlarge a circle, a unit circle has a radius of 1, and it's called a unit circle because a unit on the coordinate plane has length 1. So a unit circle on the coordinate plane will have radius 1. So let's just draw the coordinate plane. Now this unit circle, a typical unit circle, is centered at the origin. So this is 0, 0. And we'll draw the axes, which aren't going to be that straight. I'm not that good at drawing straight lines. Okay, I'll just use the ruler function thing. So yeah, and also the other side, the y-axis. So while drawing the unit circle, obviously, as I've talked about, has radius of 1. And it's used for redefining trig. Like before we used the SOHCAHTOA definitions of trig functions, we memorized that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, etc. Right? And that's just how we did stuff back then. But now there's a new definition for unit circles, and this is very useful, not just because it defines unit circles, it defines the sine, cosine, and tangent functions in a new way, but because we can now apply trig to more than just acute angles. We can apply trig, you can use sine, cosine, tangent functions on stuff like reflex angles, obtuse angles like 270 degrees, or maybe even angles larger than 360, like 1000 degrees. You can do sine 1000 degrees using a unit circle. So let's just zoom in. The unit circle, radius 1, let me just label that. So let's just do a few simple things. Firstly, how do we use it? We start, so like where's the angle? We want sine theta, we want cosine theta, we want tangent theta. We want an angle as theta. Where's the angle in a circle? Well, remember radians? Well, yeah, that's where we're going to use it. So this is the center, this is the vertex of the angle, and we draw this line. So we start from the positive half of the x-axis. So this is this ray here. And when we count positive angles, positive degrees, ignore the negatives first, we move counterclockwise or anti-clockwise, depending on how you like to say it. So you move counterclockwise when you count positive degrees. For example, if you rotate this radius over here, if you shift this line over here, this is 90 degrees, or pi over 2 radians. Right? And if you shift this line, or if you rotate it via the center for like this much, you can say that this is around, so this angle is around 225 degrees, right? Or it's around 5 pi over 4 radians. So yeah. So that's how we use a unit circle. And for negative degrees, we go clockwise. For example, this angle would be negative 45 degrees, or negative pi over 2 radians. Yes, negative degrees do exist. Now, however, how do we even work with negative degrees? Like, we've never had this concept in our life before. Well, for most people. So realize that this angle here, if you don't look at which angle it is, this angle here can be represented with the same thing using this angle over here, which, since you rotated counterclockwise, is a positive angle. And in fact, it's just 315 degrees. So you can represent negative 45 degrees as 315 degrees. Or in radians, in the world of radians, you can say that you can represent 315 degrees is like, so this is just 2 pi minus pi over 4, or so 7 pi over 4 radians. And you can represent negative pi over 4 radians with 7 pi over 4 radians. So you can just add 360 degrees to this angle. When you add a positive angle, this is essentially, so when you add a positive angle, it's the same as moving counterclockwise. We know that going counterclockwise is positive. So this is negative 45 degrees. If I add 60 degrees to this, we're basically moving 60 degrees counterclockwise, and we'll reach 15 degrees as our final answer. So this angle here would be 15 degrees. If you subtract an angle, you move clockwise. For example, if you go with 315 degrees and you want to subtract 75 degrees, you'd go back 75 degrees. Like, say the angle is over here, and you'd get some angle like that. So you get some angle like this. So if you add 360 degrees to this, negative 45 degree angle, what you're doing is you're basically rotating back over here by adding 360 degrees. So this angle is actually just the same thing as angle is the same thing as 315 degrees. So this will make sense later on as we use the trig functions here. So let's first look at positive angles. So let's look at the first quadrant, because in the first quadrant all angles are acute, so we can apply the SOHCAHTOA even if we're stuck on this. So this is 45 degrees. Now, how do I find the trig function values using this unit circle for 45 degrees, or pi over 4 radians? Well, So the definition is that the x-coordinate is the cosine value, and the y-coordinate is the sine value. Now, what about the tangent value? After some experimenting, you would realize that the tangent value is just the sine value over the cosine value. So, since our goal is to find the xy coordinates of this dot here, so this radius ends on this point, right? We have to find the coordinates of this point. Well, we can just draw a right triangle. So this is a right triangle, and we know that the hypotenuse is 1. This angle is pi over 4 radians, or specifically 45 degrees. So this means that these two sides are the same. This is an isosceles triangle. Now, using the Pythagorean theorem, therefore, we know that each side, so this side has a length of root 2 over 2. This side also has a length of root 2 over 2. Since these two, using the Pythagorean theorem, sum up to 1 and they're equal sides. So we know that the absolute value of these sides, so we know that these sides have length root 2 over 2. But are the coordinates actually root 2 over 2, or are they negative? Since we're in the first quadrant, all of the coordinate values must be positive. So the answer is that cosine pi over 4 radians is root 2 over 2, and sine pi over 4 radians is root 2 over 2. What about tangent? Tangent is just sine over cosine, which is just 1. So that's just 1. Let's try some other values. Like, let's try a different, a second quadrant angle, an obtuse angle. Let's try 150 degrees. Or you can say in simple terms 5 pi over 6 radians. So again, we want to find kind of the length of these two sides to find the coordinates, right? And to do that, we simply draw a right triangle again. So to find the length of these sides, that's our first goal. We will worry about the positive and negatives later. We know that this side length, the radius, or the hypotenuse is 1, and that this angle is pi over 6 radians. This is pi over 6 radians. And what this tells us is that that's 30 degrees. So this is 60 degrees, or pi over 3 radians. So we have a 30, 60, 90 triangle. So using that theory, and the hypotenuse is 1, this side is 1/2. So the y-coordinate is 1/2. And the x-coordinate would be, using the Pythagorean theorem, negative root 3 over 2. Why negative? Because we know that side lengths all have to be positive. But we're in the second quadrant. We're using a coordinate plane. There's negatives. We're in the second quadrant, so the x-coordinate must be negative. So it's a negative of the side length. Because the side length is just the absolute value of the coordinate. The side length from this dot to this dot is just basically the distance that this point is from the center. That's the side length. And the negative indicates the direction. It's to the left. Because if this was not negative, if this was a positive value, then the angle we're dealing with would be 30 degrees. These would be the sine cosine values of pi over 6 radians, or 30 degrees. So that's that. And so the tangent value, so the tangent of 5 pi over 6 radians is, well, sine over cosine, or y over x. So the y coordinate over the x coordinate. So that's just negative root 3 over 3.